background information. What is a linear inequality in two variables? A linear inequality in two variables is an inequality that will look like one of these inequalities I have listed here. It could be in the form of ax plus by less than c, ax plus by greater than c, ax plus by less than or equal to c, ax plus by greater than or equal to c. It is in two variables because the variables we have here will be x and y, and we know that a, b, and c are basically constants. They are real numbers. So what would be the solution of a linear inequality in two variables? Well, to find the solution of a linear inequality in two variables, we're going to graph the line representing the boundary of that linear inequality on the xy plane. And the solution would be the part of the plane containing all sets of ordered pairs that will satisfy that equation. So how do we do it? Let's see how it works. So the first thing we want to do is to graph the lines, the boundary line. Once we graph the boundary lines, we have to take into consideration that in one occasion we're going to have a boundary line that will be a dotted line. We have a dotted line when the x is less than. We have a situation of less than or just greater than without a dotted line. We're going to have a solid line whenever we have less than or equal to or greater than or equal to. Our line will be solid, which means that any point on the solid line is a part of the solution, whereas a point on the dotted line is not necessarily a part of the solution. Now, so how do we solve it? So once we've graphed the boundary line, we select a test point from either one of the sides of the boundary line. We substitute that point into the inequality, and if it satisfies the inequality, then that side which contains that point will contain all solutions of that inequality. If the test point fills the inequality, then all points on the side not containing that test point will be solution for that inequality. Now, it's a common practice, a very good practice, to use the origin 0, 0 as a test point, where there's only one situation wherein you do not want to use 0, 0 as a test point, and that is when your graph runs through the origin. So let's do some examples and see how it works. So here we have, what is the graph of the linear inequality 3x minus 4y less than 36? Now, to graph the boundary line, we can consider two important points, and that is we can find what we call the x-intercept, and based on previous videos, you know that at the x-intercept, the value of y is equal to 0. So I'm going to substitute y for 0 over there. So I have 3x minus 4y is less than. I'm going to use equal sign when you're actually finding the x-intercept. Now, I replace y with 0. So I have 36. I'm going to have 36. So then I have 3x is equal to 36. I'm going to divide both ends by 3. So I have x equals to 12. So that's my x-intercept. That is the point on the x-axis where the graph of this inequality is going to cross. Now, let's go ahead and just put a bar right here, and let's proceed to finding the y-intercept. Again, here we know that at the y-intercept, x has a value of 0. So now if I go to my original problem, I want to do 3x minus 4y equals to 36. Replace x with 0. So what I have now is 3 times 0 is 0. I have negative 4y equals to 36. Once I divide by negative 4, I have y equals to negative 9. So now I have my x-intercept of 12 and my y-intercept of -9. Let's remember that. So we're going to clear this up, but remember that our x-intercept is 12 and our y-intercept is -9. So let's go. X-intercept was 12, y-intercept was -9. So let me just draw my plane here. That's my y-axis, and this is my x-axis. So I'm going to not go by 1. In terms of y, I'm going to go by 3, 6, 9, 12, -3, -6, -9, -12. In terms of x, I'm going to go by 4s. I can go by anything I wanted to go by. So I have 4, 8, 12, 16, -3, -6, -9, -12, -4, -8, -12, -16. Now, our x-intercept was 12, so I go on the x-axis and mark 12. Our y-intercept was -9, come on the y-axis and mark -9. So the boundary line for this inequality is going to go through those 2 points. Now we have to take into consideration that we have just less than, so our boundary line must be a dotted line. This is going to be the graph of 3x minus 4y equals 36. That's the line representing. So now we must take a test point. Now our boundary line did not go through 0, 0, which is right here. So I'm going to use 0, 0 as a test point. And I'm going to substitute 0, 0 into our inequality to see if it satisfies our inequality. So let's write our inequality again. 3x minus 4y less than 36. Now if I replace x with 0, because we said 0, 0, x is 0, y is 0. I'm seeing that 3 times 0 is 0, 4 times 0 is 0. So in effect, I have 0 is less than 36. Is this true? Is 0 less than 36? Yes, this is true. So because this is true, our test point has satisfied this inequality. So every point on the side of the boundary line containing our test point will be a solution. So since our test point is above the line, all of the points on that side for our test point 0, 0 will be a solution. So any values, any order pair on this side of our boundary line would be a solution of this inequality. And you can go ahead and test it. You can take, for example, a point says 0, 6, substitute 0, 6 into this. I'm just going to try it so that you see. X is 0, y is 6. So I will have 3 times 0, for example, minus 4 times 6. And I want to know whether that result is going to be less than 36. Well, 3 times 0 is 0. I'm going to have negative 24. Obviously, a negative number is less than a positive number. Now, just to show you that if I took any other point down here, say for example, I took 0, negative 12 and plug it in. So I have 3 times 0 minus 4 times negative 12, and I want to see that it's less than 36. 3 times 0 is 0, negative times negative is positive. 48 less than 36, is that true? False. So this would not be a solution. So any point on this region down here would not be a solution, whereas any point taken from above the line would be a solution. Let's try another example. Okay, so now we want to graph this inequality. So how do we do this? First of all, I see that I could graph this using my gradient and my y-intercept. I could also graph this using my x-intercept and the y-intercept. So let's see if I can do that again. Now I'm going to take another approach to help you master finding your x and y-intercept. So I'm going to take a tabular approach. So I write x-intercept right here, and I put y-intercept right here. Now, then I take some theory of what we learned. I'm going to put x and y over here. Now, I've just said that at the x-intercept, y is 0. So I'm going to put a 0 over here. And at the y-intercept, x is 0. So when I want to find my x-intercept, I make my y to be 0 into that and then find this value. So for the x-intercept, I'm going to have 5x minus 2 times 0 minus 20. And we use equals when we are doing this. So we have 5x, 2 times 0 is 0, minus 20 equals to 0. Take the 20 across, you have 5x equals 20 divided by 5. You got x equals to 4. So my x-intercept has coordinate 4, 0, which means our graph is going to cross the x-axis at the point 4. For the y-intercept, we do similar thing. So now I must make my x to be 0. So I do first, I write the original problem down. Minus 2y minus 20 is equal to 0. So I do 5 times 0 minus 2y minus 20 equals to 0. I have negative 2y minus 20 equals to 0. Take the 20 across, I have negative 2y equals to 20. Divide by negative 2, y equals to negative 10. So basically, what I have here now is that my x-intercept is 4, 0. My y-intercept is 0, negative 10. So I can graph my inequality. I'm going to clear up this end so that we can see our graph easily over there. So I'm marking right here. I'm going to do my plane right here like this. Once I have graphed it, I will clear up my table from my left and use that space to do my test point. Marking my x-axis. I'm going to make a decision whether I should count by 1, or count by 2, count by 3. But it doesn't matter because I'm actually looking at the picture diagram here. So, well, I'm going to go by 2's in both directions. Yeah, 2, 4, 6, 8, 10. So good. I'm going by 2. So it's 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Negative 2, negative 4, negative 6, negative 8, negative 10. Negative 2, negative 4, negative 6, negative 8, negative 10. So, well, my x-intercept is 4. So I go on the x-axis and mark 4. My y-intercept is negative 10. So I come down here and mark 10. I must consider my sign of my inequality is greater than or equal to. So I must have a solid line passing through those 2 points. So now my decision, I have to make a decision as to whether the solution would be on the left side of this boundary line or on the right end of the boundary line. And because this graph doesn't go through 0, 0, this is a very good test point. So I'm going to use a test point of 0, 0. So how do I use that test point? I'm going to clean this table over here, try and use my test point over there, and be able to determine the solution and graph the solution of my inequality. So for my test point, I'm using this 5, my x is 0, minus 2 times 0, minus 20. I want to see whether that's going to be greater than or equal to 0. 5 times 0 is 0, 2 times 0 is 0, minus 20. So now I'm left with negative 20 is greater than or equal to 0. You know, this is a lie. This is false because negative 20 is actually less than 0. And because this is false and 0 is on this side, So all solutions for this graph would be the ones that lie on the line and are on the right side of that line. So this would be the solution for this inequality. Now, next problem here, we said find an ordered pair which is a solution of the inequality. One of the things that people might think about doing is to just pick up numbers and try it, but I think we can easily graph this. And because we have kind of gone over graphing this, let's do something quickly. And that is like we are stretching ourselves a little more. So we can write x-intercept right here. We can write y-intercept here. We do an x, y. To find the x-intercept, y is 0. To find the y-intercept, x is 0. We do a quick substitution here. When we put a 0 here for y, 5 times 0 will be 0. So we are left with 3x equals to 15. Divide by 5, so x, divide by 3, so x will be equal to 5. Now, when we put a 0 in for x, we're going to have negative 5y equals to 15. Divide by negative 5, y will be equal to negative 3. So we can quickly and easily mark those 2 points on our graph. Let's mark our 2 points. So I'm going by ones here. My x-intercept is 5. 1, 2, 3, 4, 5. My y-intercept is negative 3. 1, 2, 3, negative 3. And we have just less than, so our line is going to be a dotted line. So our solution can either be up above this line or below this line. Let's see, let's take a test point again. I'm going to do this fairly easy. If I take a test point, can I use 0, 0 here? Yes, I can. So my test point is 0, 0. And when I substitute 0, 0 here, I'm doing 3, my x is 0, minus 5, my y is 0. And I want to know whether this result will be less than 15. Well, 3 times 0 is 0. 5 times 0 is 0. 0 minus 0 is 0. So I have 0 is less than 15. Well, basically, this is a question. Is 0 less than 15? Yes, indeed. So this is true, which means our test point of 0, 0 satisfies this inequality. So the side containing that point is above our boundary line. So every point up above this boundary line, including our 0, 0, will be a solution of this inequality, whereas any point below this line would not be a solution. So in this problem, we're supposed to find an ordered pair, which is a solution. So we can find any ordered pair. I could look at this point 1, 1. 1, 1 would be a solution. I could look at the point even 3, 0 could be a solution. So I could find an infinite number of points that would be a solution for that. So any point up there would be a solution. And just so that we see it, even the point negative 1, which is right here, is also a solution of this inequality. Right? Let's do another one and see how we are understanding this. Good. So basically, we have to find the solution of this problem. Again, we got to take a different approach. The way this equation has been structured is basically easy to find the x-intercept and the y-intercept. Look here. When I want to find my x-intercept, I make my y 0. 5 times y is 0. So I could just cover this, and I have that x is equals to 10 would be my x-intercept. When I'm going to find my y-intercept, I'm making my x 0, so I'm left with negative for my y-intercept. I'm left with negative 5y equals to 10. When I divide by negative 5, I have y equals to negative 2. So basically, I have it. I'm going to count by ones. So on my y-axis, I'm going to go down -2. On the x-axis, I'm going to go 10. 2, 4, 6, 8, 10. Now, our line is just less than, so it's going to be a dotted line passing through those 2 points. So now we must take a test point again because 0, 0 is not on our line. 0, 0 is a very good test point. We can use another point, but I'm going to stick to 0, 0 because it works fine for us. So now I'm going to substitute 0, 0 into this equation. And so to do that, for clarity purposes, I'm going to clean here and clearly show you what we need to do to check. So we are using 0, 0, which means x is 0, y is 0. So I'm doing 0 minus 5 times 0. And I want to see whether this result is going to be less than 10. That's 0 minus 0 is less than 10. So I have 0 is less than 10. Is 0 less than 10? Yes. So this result is true. So the side containing that point 0, 0 will include all solutions of this inequality. And that side happens to be above our boundary line. So the inner value on that region would be a solution to our inequality.